Hello and welcome back. All right, the next sample we have here is extraneous variables and sample bias. So again, I just have the screen shade up. I know you have everything, but it's a little overwhelming, lots of reading here. So CompuWiz, a computer training institution in London, features the profiles of some of its young graduates in the newspaper. So not uncommon to show here are the school success rates for attraction purposes. The number of months training that these graduates took, the job title, and income appear in the advertisement. So we want to analyze the promotional data, use the model created in Part A to predict graduate with 20 months of training, and is there a linear correlation in the data itself? Okay, so here we have all the information provided, and they're saying that they have a fantastic success rate. So let's talk about that for a second then. Again, in Google Docs, if you go to example number 2, all the information is there. So let's take a look at month's first income to start with. All right, is there a correlation between the two? So, creating a chart, more, scatter, scatter, customize. So we will have, let's go income versus training time. And scrolling down on the horizontal, let's put the title months. And again, let's go 0 to 12. Oops, that's good job there. It's 12. And on the vertical, title there is income. And it's all in thousands. So I gotta go up to maybe 100. And there we go. So initial analysis here is, there's a pretty strong linear correlation, and that's what I'm going to type up here in the right area. So, what do we got here? A, analyze the promotional data, so I'm going to analyze it. There appears to be a strong positive correlation. R equals, and let's take a look at what the R value is going to be. Scrolling down, let's do a linear trend line. Give me an R value. So again, remember this is R squared. The 0.806, I need R when we're doing linear. So non-linear, R squared, linear R. So I got to take the square root of the 0.806. And that turns out to be 0.8977, so 0.9 basically. It's an R value of 0.09. Okay. A very strong relationship. So that's our conclusion. That's the analysis based on what was given. Okay. B part. Use the model created in A. Okay, so we got to find a model. So y equals, and I'll cheat a little bit here, where y represents income and X represents months. Training. All right, backtrack a little bit. Go back to my Google Doc sheet here and give me an equation. So 5.4x plus, let's call it 32. So 5.4x plus 32. So there's the trend line. All right. And B part wants us to predict 20 months. So at 20 months, we would end up with y equals 5.4. I'm just going to do it all on here. That's 32. Y equals, comes out to be a cool $140,000. So 140,000. So therefore, 20 months of training will land a $140,000 job. All right. Well, everyone should go to this school because this school is bloody awesome. So that's all the question 1 and B. All right. Now C. If we look at C, does the linear correlation show that CompuWiz's training account training accounts for graduates' high income. Okay, so first of all, do we believe the linear trend that we have found in B part will continue? Um, First of all, I'm going to say the linear trend from part B. I'm going to create a bit of extra room here. Is I would say is for a limited training period, because we are gaining, if you look at the 5.4, that's $5,400 per month you stay in the training session. I mean, you're going to be making an exceedingly large amount of money in a very, very short period of time. So I would say that there's some factors here. All right, there are some factors to consider in the data. Okay, so what's the first one? Let's talk about, first of all, if we take a look at the jobs. So software developer, programmer, system analyst. If we look at who's making the most money here very quickly, we see software developer is making 85,000. Systems analyst is making 72,000. So I would think that the field chosen affects starting income. Because if you're going into a less needed field, for example, there may be more computer technicians out there than software developers. So there's it's a hotter spot for harder to get software developers. So the greater the demand, the better. The other thing that might play a factor here is the job experience. So previous job experience. So we have no idea, these individuals. For all I know, Sarah is a 45-year-old software technician that has experience in the field and now is a software developer. So it's something that, she has the background and the abilities, shown track record, etc., etc. I mean, and the same might be for Eli. You don't know the ages of these individuals. Are they starting right out of school? Are we looking at, 20-somethings, or are we looking at people that have got 20 years of experience? We may also want to consider, connections. So are these individuals going back to work for family, perhaps? Or are they sent there by their company? If Sarah had this program, 9-month program, she would be a more valuable asset. So was she coming from a $75,000 job, company center for the training, and so on and so forth? So there's a whole bunch of other factors that play a role in here. And I'm not going to go and spend a ton of more time on it. I'm going to leave it at that. Because the next part is, to discuss problems with the sampling technique. So what are some of the problems with this sampling technique? First of all, I'm going to go back to the original, sample A. Not enough in the sample to determine a trend. So, I mean, this is fine for promotional material, but as individuals, reading this article, we have to recognize that, we're only looking at a select few. And I mean, this could have been intentional selection here. Of course, I'm going to pick my most, successful graduates because they provide, the best showing for the school itself. So we're not looking at, how many jobs. What about other graduates? Success. Did they get jobs, income? The school's gone out and selected just a few individuals to report on. So are we looking at kind of that skewed approach or analysis on that? So there's other factors that play a role here. So when you see advertisements in the newspaper and they're showing, look at what all our graduates do. Remember, there's more than 6 graduates from a school, so they have carefully picked the right ones for their advertisement purposes. And that can be said too about anything. If you're looking at banks or investment companies, look at how much we have made our investors. Are we talking in the last 6 months? Are we looking track record of 10 years? So you got to kind of take all of those factors into account when you are critically analyzing an advertisement involving data. So you got to be very aware of the different factors involved. All right, so we'll leave that example and I'll move on to the next. And again, just got the screen shade up just to not overwhelm you with all the information. So now we're talking about hidden variables now. So the situation, Arts Council is considering whether or not to fund the startup of a local youth orchestra. Council has limited funds and wants to know that the investment is going to be, the best investment possible. So one measure of success is the number of your orchestra players who go on to professional orchestras, and that should be youth, not your. As I read that, I'm like, that makes no sense. There we go, youth orchestra players. So I'll get rid of this now. So again, here is our data. Okay, we have number of youth orchestras across the country and number of players becoming professionals because it is a limited field. So A, does a linear regression allow you to determine whether an orchestra should fund a new youth orchestra? And can we draw conclusions from the data? So again, if you go back to the Google Docs, get rid of this, I have example 3, and the information's already there. Okay? So I want to see, is there a relationship between youth orchestras and the number that become professional players? So we're going to look at and do an analysis of the data. More scatter, customize. So we are looking at professionals versus youth orchestras. Oops, close enough. So on the horizontal axes, we have our youth, and I'm just going to leave it at that. We'll go 0 to 20. Whoops, and vertical, professionals, and we'll go 0 to, yeah, we'll leave it as 40, that's fine. So when I look at the data, okay, at first glance, and this is where you got to be careful, at first glance, your knee-jerk reaction might be to say, hey, there's no relationship here between the two, okay, because you could say that there's a zero correlation, and probably if we went through and ran this through a linear and our squared value, it is virtually zero. So definitely I would say, yeah, there's no linear relationship here. But there's something that is kind of funny here, and I'm just gonna copy and paste this in so I can draw on it. So I've brought the chart in here, and if you look at the data, there's kind of an interesting pattern because it's not your usual scattered no relationship pattern, because there is a pattern, just maybe not as apparent the first time running through this. This data seems to form a line, and this data seems to form a line as well. So it looks like there's two relationships going on here at the same time. Because if we do two lines of best fit for the data, all of a sudden we see, wait a minute, there's a huge strong correlation here and a huge strong correlation there. So we're looking at, does linear regression allow you to determine, oops, I want to answer that question. So A, no and yes. Using all the data, no linear relationship seems to be in the data. However, when plotted, there appears to be two strong positive linear correlations within the data. For the data to be analyzed, we should separate the two parts and analyze each separately. Okay, because when I look at that, there's definitely a relationship that exists. Okay, there is the example there. So I want to finish this example up quickly in the next video, and then you're done and off for the races.